Parallax method. Objective: to learn to apply parallax method to find distances of celestial objects. To measure lengths of astronomical scale, direct methods of measurement are not helpful. Large distances, such as the distance of a planet or a star from the Earth, cannot be measured directly with a meter scale. An important method in such cases is the parallax method. Let us look at the working principle behind parallax method first. Hold a pencil in front of your eyes against a wall. Look at the pencil first through your left eye, A, closing the right eye. Then look at the pencil through your right eye, B, closing the left eye. You would notice that the position of the pencil seems to change with respect to a point on the wall. This is called parallax. The distance between the 2 points of observation is called the basis. In this example, basis is the distance between the eyes. Distance of the pencil from the eyes can be deducted from the basis and the angle between the line of observations. Let's use the parallax method to measure the distance d of a faraway planet S. We observe the planet from two different observatories, A and B, separated by distance b on the Earth at the same time. Measure the angle between the two lines of directions along which the planet is viewed from these 2 points. The angle ASP equal to theta is called the parallax angle or parallactic angle. We can consider AB as an arc of length B of a circle with center at S and radius d. Length of the arc is equal to the product of radius and angle made by the arc in radians at the center. B is equal to d theta, where theta is in radians. D is equal to B by theta. Calculating B and theta is relatively easy, from which we can determine the distance d. Having determined d, we can employ a similar method to determine the diameter of the planet. Let alpha be the angle between two directions. When two diametrically opposite points of the planet are viewed through the telescope, the angle alpha can be measured from the same location on the Earth. Since d is known, the diameter x of the planet can be determined. X is approximately equal to the length of the arc with radius d and angle alpha. Hence, the diameter of the planet X is d alpha.